Apparently so. Okay, we are recording. Well, welcome to day two. What we're going to do today is really do the rest of the native trees of this sort of northern part of the Chicago region. I mean, one of the trade-offs for moving, that I really enjoyed the pace we worked with yesterday of doing 8 or 12 trees and then doing a little quiz and review. That means I do fewer species. And so what we're going to do, if I can convince Jackie, is sometime after the busyness of the fall, we'll do a webinar just on the shrubs and exotic trees and shrubs of the Chicago area. I've mentioned a few of them along the way because sometimes they're lookalikes or similar to the native trees. But we'll really focus on those a little bit later. So today we're really going to continue talking about the native trees of the region. And let me get rid of this. Okay, here we go. So we're going to really start where we left off yesterday. I'm going to review the cherry and hackberry I think we were working with just before we finished yesterday. And we're going to be looking now at trees mostly with simple alternate leaves, at least for a while. We'll be looking at those, and that's probably the most common arrangement you find in nature are simple alternate leaves. The exceptions are opposite leaves. The old saying, if you're talking about trees, that if it's opposite, it's a maple, ash, dogwood, or horse chestnut. MAD, horse, mad horse. That was the one I learned. As long as you restrict yourselves to trees, that works pretty well. In our area, since we don't have any horse chestnuts and we don't have any dogwoods that are trees, if you see something that's opposite, it's a maple or an ash. But here, remember, ash has a compound leaf. We're going to look at now at simple alternate leaves. So we'll start back with cherry again. Remember that review that this has the lanceolate leaf shape. There it is, the lanceolate leaf shape. Now look at choke cherry for comparison. That's really widest here out toward the tip, but it's a much broader leaf. We call that an ovate shape, except ovate has the broadest area toward the middle. And so when we flip a leaf around and the widest part is toward the end and the narrow part is toward the petiole, we put the prefix ob, ob. So this would be ob ovate. If we had a leaf that was lanceolate in shape, but the petiole was at the narrow end, we call it ob lanceolate. There are even ob cordate leaves. I've never seen one, but I'm told there are ob cordate leaves. But ob lanceolate and ob cordate or ob ovate are really not that unusual. So the leaf shape is different. You'll see the surface of the leaf is not as shiny. Yeah, that's so easy to see in person, harder to see in pictures, but the veins are slightly impressed here. The leaf has a dull green upper surface. This is very shiny. See how these lateral veins are just invisible once the light is shining off that upper surface. Flowers are very similar, both in racemes, and a raceme means you have a central axis to the flower cluster, and then each little flower comes off of it, is on its own little stalk coming off of that central axis. We've talked about the bark of black cherry, the burnt potato chips stuck to the tree. Choke cherry, by contrast, it's a much smaller tree to shrub. You will see it as a small tree sometimes, much more often in the Chicago area as a shrub, and it has a very different bark. These are pretty good pictures of it. Kind of hard to put bark into words sometimes. The English language doesn't work very well for patterns. And that's the raceme of flowers now in fruit. And here you can see the central axis of the raceme and the drupes arranged along that axis. Talked about the twig with the relatively short buds, fairly soft to the touch, and in comparison to choke cherry with a bud whose buds are longer and more pointed and firmer. So when you hit that with the soft part of your index finger, it's starts to cause a little pain. This one's much softer, and you get a little green and red colors sometimes in these black cherry buds that are absent from the choke cherry buds. Hackberry, if you remember, this is where we stopped yesterday, but it has that oblique leaf base and the 3 veins from the base. Very different from either of the cherries, which really had a strong central vein, and then all the laterals came off of that central vein. And hackberry has that really weird, it's really a lateral bud that ends up at the end of the twig, but it, for some reason, turns almost 90 degrees to the side of the tip of the twig. So if you see that, it's about the only tree in our flora that does that. And that lovely raised, hard, corky ridges on the bark, unlike anything else in our flora. If you go south, there's a sister species. This is Celtis occidentalis, this is Celtis laevigata. As you go south, central Illinois and further south, you'll start to see Celtis laevigata, which has a similar bark, not quite as many corky ridges, but otherwise quite a similar tree. And this is the drupe. We talked about the structure of the drupe yesterday. The bony endocarp, inner wall of the ovary, matures into this bony covering for the seed. The middle of the ovary wall turns into the fleshy part that, in the case of peach that you eat, or that's what the birds are after when they eat a hackberry, and then the exocarp, the outside of the ovary wall, becomes the skin of the drupe. With the elms, there's 2 species that we're going to focus on here. Let me back up just for a second. So American elm and slippery elm, those are the 2 native species we're going to encounter in the Chicago area. They are really quite similar. If you put your hands on the 2 of them, the slippery elm leaf, despite its name of slippery, is much rougher than the American elm leaf. Beware, because American elm a sprout growing out in the open, the leaves will really be quite rough. I used to say with the, when I was teaching trees at the University of Michigan long ago, that if you wanted to lower the class average, you just did a little American elm sprout out in the open, and everyone would put slippery elm in, so they'd miss half the points. So something always to look out for is that when these are growing out in the open, sometimes the leaves can really be quite rough comparatively. So the best ID character is the one you're looking at right here, which is these branched side veins. Now, it seems like a very minor character. Look at all the branches on the side veins. If you look closely at the American elm, you'll see 1 or 2 if you look really closely. But again, it's a comparative feature you just have to get looking at. There are so many more of these. And you think that's a really small feature, and I must have like eagle eyes to see it, but I really don't have very particularly good vision. It's just that when I see elms, my eye instantly goes to the leaf and to the edge of the leaf and looks for the veins. And so I see this just walking down the trail and see an elm and quickly identify it as either slippery or American elm just by those veins. So it's a really obvious feature once you learn it. When you're learning it, it will seem pretty obscure. But once you've learned it, it's a really good and pretty easy feature to see. The edge of both of these elm leaves is called doubly serrate. I think I have here, there's a picture that has all the different leaf edges and the technical names for them. Botanists love terminology. So doubly serrate means you have big serrations and then little serrations on top of the big serrations. And you see in each of these big tooth, little tooth, big tooth, little tooth. And there's your doubly serrate there. They put 5 or 6 little teeth on top of a big tooth here. But essentially, it's 2 orders of serrations. We call it doubly serrate. And you will sometimes see that if you look at, we're going to do a tree called blue beech or musclewood, which if you look at it in the southern United States, where it's a bit more common, it has a doubly serrate leaf. When I see it in the northern United States, it's more often singly serrate. So it does, this feature does occur on some other species, but it's by far the most common on elms and becomes a thing that we sort of automatically associate with elms as a doubly serrate leaf. It has that oblique base again that the hackberry had. One side bigger than the other, not completely symmetrical.
Hey, Tom, we had a question.
Okay.
Do American elm and slippery elm hybridize?
Not as far as I know. I've never seen an elm tree that convinced me it was a hybrid. That doesn't mean they don't, but I've never seen one that seemed convincingly midway. Typically in a hybrid, what you're going to get is something that's midway between the two parents. The way all the genetics work, it's not quite like a dominant recessive, like my mother had blue eyes, my father had brown eyes, and I ended up with blue eyes, not brownish blue eyes. But when you cross two species, like two elms, or you'll frequently get hybrids of like smooth sumac and staghorn sumac, what it will look like is just halfway between the two. I've really never seen that with the elms. It doesn't mean it doesn't happen. Maybe you'll find one, but I haven't seen it. The Siberian elm, which is the introduced species, this was the tree, logs of which were brought into the United States that carried the bark beetles that carried the fungus that caused Dutch elm disease and led to the virtual decimation of American elm populations through eastern North America. It's still around. The Dutch elm disease doesn't tend to kill the tree until it's well past the reproductive age. So elm is pretty common as a small to medium-sized tree in our area still. You rarely see the big ones anymore. And as far as we know, there are no resistant genes in the population. And when you find, and I know of a few nice large ones here in Libertyville, it's simply a matter of chance. And when the disease finds them, they'll probably die generally within a couple of years. The Siberian elm leaf is much smaller. I mean, this size comparison is sort of artificial. This is a photograph, but that's pretty reasonable comparison. Much smaller leaves. Because the leaves are smaller, the oblique leaf base is not obvious or it's absent altogether. And it's really hard to see double serrations on this. I mean, more singly serrate. But otherwise, it's sort of like a mini American elm leaf. The bark of the Cyprian American elm is, I guess, similar at first glance, but if you break off just a little piece of the elm bark and look at it, you see that the American elm bark is made of alternating layers of cork that are reddish brown and very light colored, and reddish brown and light colored. So we call that the Oreo sandwich cookie bark. Whereas slippery elm, it's a uniform reddish brown color. Both barks are fairly soft and corky to the touch, so they compress under your thumbnail. Once you get used to American elm bark, you can see those two corky layers in the color of the bark without ever breaking a chip off. But that takes a little experience. The slippery elm, by comparison, has a to me, in my eyes, a very pretty slate gray color without any variation. That reddish brown color oxidizes to a slate gray on the surface. The Siberian elm bark is visually, when I look at it, it looks more like an American elm bark. And if you cut into the bark, it does show alternating cork layers. But if you get used to touching things, there's no mistaking, and Siberian elm bark is much harder and rougher to the touch. A lot more stone cells and less cork cells in the bark. So while it looks similar to American elm in the bark, if you touch the two, it's really very different to your hand. There's American elm buds. We always say with American elm, you have a brown twig and brown, sort of uniformly neat little chestnut brown buds. Whereas with slippery elm, the twig is grayish in color, generally a little bit hairy, smooth on the American elm, and the buds have black scales toward the base, and then generally reddish hairs coming out from the bud scales toward the tip. That's one of the best. If you have buds by late summer and fall, if the buds are present and you can get up and you can see the leaves or the twigs, then that's by far the best character to tell the two apart, that and the bark. Siberian elm, as you encounter it, I didn't have a picture of the sort of fishbone pattern of branching. Most of the lateral buds seem to break dormancy, and so it's this because I don't really like Siberian elm. I can't call it a pretty fishbone pattern, but I guess to some eyes it would be a pretty fishbone pattern is all the lateral buds break, and you've just got, you know, one branch after another going in either direction. These are the flower buds that just bead the twigs by fall when the buds are, and all through the winter, and will expand and look like large beads in the springtime.
Well, welcome to
let's
Coral Woods.
talk
And the reason
a little bit about
I stopped here today
fire
is
and,
really to
and
talk about a phenomena that looks very
the invasion
different
of woods after
from what
fire.
we saw in Glacial Park with the invasive trees and shrubs there, which were all Eurasian exotics. That phenomena, basic phenomena, has played itself out right here, and yet it looks totally different. As you look around you, the dominant trees are white oaks. By far, probably 9 out of 10 large trees are white oak here, and yet I can see a few sugar maples. They're a little hard to pick out from the camera. Their bark is not that different from white oak, but two of them that are, you know, ballpark, maybe 100 years old. They could be a little more than that. I mean, it's awfully hard, particularly with sugar maple, to tell its age from its size. It grows very slowly, or can grow very, very slowly. But one thing we know about the ecology of those two trees is they don't reproduce under the same conditions. White oaks require lots of sunlight. If you have lots of sunlight coming into an area, of an abundance of other growth. Sugar maples just don't grow well in those situations. They have a huge competitive advantage when it's shady. They are very tolerant of shade, and so they can establish in shady conditions and slowly grow up and take advantage if any one of these large trees breaks off or dies. That reproductive strategy works in a sort of a woods that has relatively light disturbance and is a fairly shady woods, whereas oaks require an open woodland savanna situation in order to reproduce. And so we've got these two different messages coming at us here. So the basic story when you're at a place like this is that if you go back to a pre-European settlement landscape, let's say 300 years ago, you have Native Americans in the area that are burning the area pretty frequently. We don't know exactly how often, maybe every couple of years, maybe every 5 or 10 years, but fires are coming through here periodically, and that puts a huge stress on most woody plants. Most woody plants just won't tolerate that, which is the reason why oaks, which are tolerant of frequent fires, dominated like 95% of the trees, and that's not an exaggeration. If you look at the public land survey notes of the early 19th century, there were just oaks everywhere. So that fire gave them a huge advantage, but at the same time it disadvantaged a whole group of woody plants, a whole great number of species that survived in the Chicago area in what we call fire refugia. So in coral woods, lower on the slope there were refugia, where sugar maples and elms and ashes could survive through that long period of frequent fires. And as soon as European settlement happens, Native American fires stop, those plants are migrating out of those refugia into the surrounding oak woods. And because there were no longer any fires, or very, very few fires, settlers occasionally set fires on purpose or by accident, but very few fires, they migrate out and fill in under these oak woods. So as we look in the oak woods today, we can see it's got a huge understory. There are very, very few, if any, small oak trees around here that are less than 100 years old. And yet there are lots of little trees. There are elms, there are ashes, there are mostly sugar maples, there are ironwoods. Depending where you are in the woods, there's quite a diversity of those relatively fire intolerant natives that migrated out from the refugia into this area during the 19th century. So it's essentially the same phenomena we saw with the exotics, only here we had a native population nearby, and evidently in the surrounding landscape, this came out of farm area disturbances much earlier in the 20th century, and there simply weren't any honeysuckle and buckthorn and white mulberry trees growing nearby, and so they couldn't invade the woods. The natives invaded these oak woods, and so they transformed the ecology of the oak woods to those of the sugar maple woods, or at least a closed forest, and so the ground flora has shifted, greatly. So the same series of changes. My question to you, and I'll leave it as an open question, because I've asked this question to many groups over the years, is when you look at this, you seem to find it very easy to go in and clear honeysuckle and buckthorn, because those are exotic invasives, and we all know we should dislike those. But what about here? Same thing happened. The same displacement, or at least much of the same displacement of the native oak savanna herbaceous flora, gone because of all these other trees that have grown in under it and provided shade. What do we do here? Restoration is a tougher decision here. But I wanted to leave with that question, because I think it's the important question to ask yourself about the importance of ecological restoration. Easy decision to make when you're cutting down buckthorn. That's become a sort of knee-jerk response on our part. But when you're looking at elms and sugar maples, it's a little bit harder, isn't it? I'll leave you with that question. I'm not going to answer it for you.
John, we had a question.
Okay, go ahead.
Is the Siberian elm also susceptible to Dutch elm disease?
No, that's the kind of the issue. That's why it was brought, well, after Dutch elm disease, it was brought into the country to fill in places because it isn't susceptible to Dutch elm disease. It was planted widely. You'll see it in the city of Chicago and some of the parks because it's not affected by Dutch elm disease. So to my eye, it is not nearly there isn't any other elm that is as beautiful in a city setting as American elm. Unfortunately, it is the most susceptible to Dutch elm disease, so it's essentially never planted anymore. Siberian elm, what you find along city streets today are often hybrids, where they have hybridized Siberian elm, perhaps other Asian species that are resistant. The disease came from Asia, and they've taken Asian, sort of resistant Asian elms and hybridized them with American elm and tried to create things that will survive or resistant to Dutch elm disease. And some of them are better than others visually. None of them, to my eye, have the beautiful form of an American elm. But maybe I'm a little biased. But Siberian elm is not susceptible to Dutch elm disease.
Thank you.
So we're going to do hornbeam now. Now, just as a group, these are two species, both in the birch family. The first one, now the word ironwood can be used for either. If you go to the southeastern United States, the word ironwood is generally used for Carpinus, or what we call musclewood or blue beech up here. So that name ironwood can be used anywhere. I just used it in that last video to refer to Ostrya virginiana. I think most people in the Chicago area call it ironwood, so you're welcome to call it ironwood. So we have a leaf that looks superficially like an elm, but what are the differences? Why doesn't this look like an elm? Well, look, the base is pretty symmetrical, so that's not like an elm, and the leaf margin just looks closely, sharply serrated. I don't really see any evidence of double serrations here. One of the things that not quite as obvious from the pictures, the twigs, most things in the birch family are very fine, thin twigs, very delicate twigs. And the bark, bark is one of those patterns. I think people scratch their head a lot with the bark of trees and learning that leaves, for one reason or another, are often the easiest ways for people when they're first starting to learn trees. The bark of ironwood or eastern hophornbeam is very characteristic. It has all these vertical lines in it, and if you touch the bark lightly with your hands, you'll find little pieces. It sort of peels in these tiny little vertical strips, and if you slide your hand over it, tiny little pieces of bark fall off. And the leaves, and this is another tactile sensation, these leaves have the most wonderful soft fuzz on the underside of the leaf that, to my thumb and index finger, feel unlike any other leaf in the Chicago area. It's a lovely soft fuzziness. You need to try that one out for yourself. And the hop in the name is because the fruits look like hops, I guess. And yeah, they do look like hops. They're not closely related to hops at all. This is all the flowers in the birch family are in catkins, so a central axis, and the flowers are attached along the central axis. And here, the matured ovary and a little sac-like covering are just attached along the central axis now. So it looks a bit like hops. It's not related to hops at all. If you tried to make beer out of it, it probably wouldn't taste very good. Oh, and here's some lovely identification feature. Late summer are these lateral buds that turn out at about 45 degrees from the twig. Really obvious feature once you learn it. Unlike elms, unlike mulberry, any of these other plants, cherries that have simple alternate leaves, that bud turned down at 45 degrees is really unlike any of those. Now let's look at musclewood for comparison. This is the other tree with simple alternate leaves in the birch family, and the leaves look quite similar, really very similar. It's not easy just looking at the leaves to tell them apart, other than if you go up and touch them. These are not soft and fuzzy underneath, so that is very different. You see here just a little tendency toward a double serration here, slightly larger serrations with fine serrations on top of it. So there's that tendency. It's not this one doesn't look like that very much at all. So it's a lot of variation in Carpinus, regional variation between individuals on that feature, but I don't associate the double serrations with Ostrya, the eastern hophornbeam, nearly so much as I do with Carpinus. The bark, hence the name musclewood, it looks like sort of all the weightlifter bodybuilders, biceps and all that, when they're taking lots of steroids, you end up with these just tremendous bulging muscles, and that's a nice descriptive name for musclewood bark. Smooth, gray, rather pretty bark. Now, often you'll see this in nature. I often see it so covered with moss and fungus that you can't really appreciate that smooth gray color, but this form, the shape of it is still there. Here's the bud, and notice how these buds pretty much hug the twig. So even though birch family twigs very thin, the leaf has a similar shape to a hophornbeam. This one is different because it's smooth and not fuzzy, and the buds on the twig are what we call oppressed. They're tight to the twig. If you collect a twig of Carpinus and let it dry for about a day, the buds are very four-sided. Not quite as obvious when they're still moist on the tree. You can see a little bit of a flat side on these buds, but maybe you can't see that. I know it's there and I can see it, but if you get a chance, these are sometimes planted along city streets more often than I see Ostrya. Both of them are pretty trees. I think I said yesterday, both of them planted around our house today. We planted them last year, so I love both of them, and really nice, sort of small to medium-sized trees, very shade tolerant. They occur in the understory of larger trees.
Question.
Okay.
Does any conservation area have more ironwood than another?
Boy, I haven't seen that much in McHenry County. I see it when I go to, state parks like Apple River Canyon State Park and Star Rock State Park. Generally want to be in a place that's a real fire refugia. Both of them are relatively, well, musclewood, very thin bark, generally occurs near streams. I can't tell you, I should know that, but I can't tell you where to see that in McHenry County. If you look around the Chicago area, you'll find it near streams in areas, often with sugar maples and basswoods in the same area. Ostrya, the hophornbeam, is much more broadly distributed in the upland oak woods. Again, it was not common at all in pre-European times, but it has spread rather quickly with the absence of fire, and is it's just generally distributed through the upland woods in the Chicago area. You'll see it in lots of places. But I don't know where to point you to see musclewood. If anyone else knows, just sing out. I think I've seen this in Ryerson Woods in Lake County. But I draw a blank when I'm thinking about McHenry County. Here's that characteristic birch family form again. Remember, the flowers are in catkins, and here the fruits again are arranged along a central axis. Here, the accessory part isn't a little sac, it's a wing, but the nutlet is attached to that central axis. Both of them have rather peculiar and somewhat ornamental fruiting clusters. Okay, here's our first quiz for the day. How about this one? Take a look at the leaf, the margin of the leaf, venation of the leaf.
You guys can type your answers in the chat.
Well, if we look at this leaf, this is a simple leaf. We can see somewhat lopsided at the base, that oblique base. There's a clue. We look at it as veining, sort of feather-like veining, but look at how the veins branch along the edge. And it's not easy to see in this photograph, but you can start to see some double serrations there. So this is a slippery elm. How did we do on that one?
Got a lot of guesses for American elm.
Okay, well, you're very close. I mean, this is good. I mean, you're getting really close. The American elm is going to come up next. And so look at this by comparison. I can see a branch here, and I see sort of faint branching. But if you look at this one, you see it's a comparative character. And I know you're thinking I'm splitting hairs, but believe me, if you keep looking at this in a few years, it will be obvious, and you'll see it walking down the trail without even going up close to the tree. It's an easy character to see. It's just subtle, and we're not used to looking at these subtle characters. That's one of the lovely things about studying trees, is that these things will appear to you. The things that you couldn't see, you'll start seeing, and that just opens up this whole other world of beauty in trees, is seeing all these little subtle characters and distinctions. So that was slippery elm, American elm. How about this one?
Getting a few guesses in the chat for Siberian elm.
Yeah, that's it. I mean, it's hard to judge the size of the leaf from this photograph, but in this case, it does have a bit of an inequilateral base. Depending on the book you look in, they'll often claim it really doesn't have an inequilateral or oblique base. I've used the term inequilateral for 40 years, so it's hard to stop. Bit of an inequilateral base, but you can see the really pretty much single serrations along there. So that pretty much excludes, even though you can't judge the size very well, American and slippery elm. Both the ironwood and the Hophornbeam and musclewood have much longer leaf, longer, thinner leaf petioles, much more delicate appearance to the plant. Okay, how about that one? They don't have much to go on with the twig and the bud. They're too small, but look at the sheen of the leaf, the light shining off the leaf. Looks great. So what do we have for this one? This one is...
A couple of guesses for black cherry.
That's correct. So this is Prunus serotina, black cherry. That shine on the upper leaf surface is another thing. You know, it's I've been doing this for a long time, and sometimes it's hard to go back and try to see these plants through the eyes I did 35 years ago. Now when I walk down a trail, I see black cherry 50 feet ahead if it's a sunny day, because the light shining off the leaves creates these highlights that are so characteristic of black cherry. So I recognize the plant even before I'm close enough to see any of the finer features. So how about that one? Look at the veination of the leaf. So we have three main veins right from the base here. Not that fishbone pinnate, strongly pinnate veining of the elms, but at least at the base we have three main veins. That's hackberry. Celtis occidentalis. How do we do on that one?
We got a couple guesses for hackberry and also ironwood.
Okay. Ironwood would have a somewhat longer, thinner leaf petiole, and it would have ironwood has a very regular pinnate veining, so it has a strong central vein, and then all the laterals come off, just like fish bones coming off of the backbone of a fish. So, but they're all close. I mean, they're close in terms of general leaf forms. How about this one? Here I gave you several things to go by. We have those peculiar winged fruits and the simple alternate serrate. He kind of maybe suggests a little double serrations, but this, I'm making that up, but the serrations, the big serrations are so far apart, almost has to be some small ones in the middle. This is Carpinus, musclewood. Yeah, those fruits are very distinctive. The only other thing you'll see like that is the European Carpinus betulus that's sometimes planted along city streets, a large tree that otherwise looks very similar to our native Carpinus caroliniana. How do we do on that one, Jackie?
We got a few musclewood, Carpinus, Hophornbeam, and cherry.
Okay. They're all remember the cherry has a drupe or a berry-like fruit, so that would exclude these winged fruits. Would exclude that. You know, the Hophornbeam has those little hop-like fruits with the whole cluster is smaller than this. The leaves and twigs from this angle would be you couldn't tell them apart, but the fruits here give you the clue that it's Carpinus musclewood rather than ironwood. And that's its sister species, the ironwood there. And you can see, really, if you were looking just at the leaves, you really couldn't tell them apart. But there is that characteristic hops-like fruit. Sometimes you'll see that on beer manufacturers will put that on their case to emphasize what ingredients are in the beer. But so that's the Eastern Hophornbeam. So let's move on to some other plants with simple alternate leaves. And this has always been I think one of the prettier plants of our region. There are actually a number of service berries in our area, or June berries. The little they look like tiny little apples. They're actually these. Some of the service berry fruits are rather hard. These are very juicy and sweet. We have one growing right next to Weed Brick Barn that has nice, juicy, sweet fruits. I think it's probably Amelanchier laevis there. It has lots of other names. The service berry is because it flowers very early in the spring. And it was given that name in the northeastern United States because it would flower very early in the spring when people were burying their dead. These were early settlement days when people died during the winter. The ground was frozen. You couldn't bury the dead. You had to wait until the spring. And in the springtime during those funerals, the service berry would be in blossom. So I think it's kind of a pretty reason for the name. Juneberry, just because of when the fruits hatch. If you go to Michigan, they'll call these sugar plums. At least Michiganders I knew when I was at the University of Michigan. Now look at this leaf base. Look how it comes in like a heart. That's our cordate leaf base. I don't think I put the leaf tip on here, but this is a sort of short acuminate. Remember, the acuminate has this double curve, convex, concave. So a bit of an acuminate tip and a cordate base. Oh, there it is. A bit of an acuminate tip. You might call it cuspidate. That word is actually rarely used by botanists. So you generally use the word acuminate or short acuminate for something like this rather than the word cuspidate. Here are the buds, a really good identification feature for serviceberry. These long, the buds are fairly soft to the touch, so they're not sharply pointy. The scale has this reddish color by the fall, and the scales are long and pointed. If there's another plant that actually occurs in the Chicago area, quite rare. West of the Chicago area, if you go to Nachusa grassland, some of those sandstone outcrops will have black chokeberry growing on it. This is planted as an ornamental, and you'll see a superficial similarity to the buds between the two, but the buds here are much more chopped off. The scales are much more chopped off at the tip. So if you're stopped on the street by someone, complete stranger, and they ask you about the difference between serviceberry buds and black chokeberry buds, you'll know the answer. You can just tell them the serviceberry buds are pointed at the tips, and the scales are pointed at the tips, and the black chokeberry buds are just sort of like they were snipped off by a pair of scissors right at the tips. Bud still is red and very similar in shape to the serviceberry. And serviceberry has this lovely mottled gray bark pattern, a little bit similar to hickories, as a matter of fact. Nothing else about the tree looks like a hickory, but the bark has a similar modeling of silver and gray colors.
All right, I want to talk about roots right now. A very important part of trees, obviously, but I want to dispel a very common mistake people make about trees. They think that because the tree, like this basswood, is 30, 40 feet tall, that its roots, that the root goes down into the ground some similar distance, and that's not really the case at all. The roots in the top are totally differently shaped because they grow in very different environments and they're doing very different things. The shoot needs to grow up and find sunlight, so it in trees tends to be vertically oriented, and it's trying to get its crown of leaves up there in competition with other trees around it to keep at least some of its leaves in sunlight. The roots are very different. They spread out from the base of the trees like a big pancake. There are a few roots that go down, that sinker roots, or sometimes we could call them tap roots in some species. But even in oaks, the taproot is really early in life, and that sort of goes away. It will still have what we call sinkers, roots that go vertically down, but still most of the root distribution is near the surface. It spreads out. And why does it do that? Why wouldn't it keep going down, 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 deep in the ground to find water? Well, there's a couple of reasons why it doesn't do that, because here, the roots can't grow below a seasonal water table. So wherever the ground is saturated for a prolonged period of time, the tree can't grow any roots. And so there's a limit to how far it can go down just based on a seasonal water table. Along this slope, that might not be quite the limitation it is in some other places. But there's another reason why tree roots just don't go down, 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 down. It's because of where they are. This is on a glacial moraine. This is glacial till, and if I were to start digging a hole here, you would see me eventually, if I lived that long and got down about 5 or 6 feet, you would see me bringing up these big chunks of clay, or glacial till. And by the time you get 5 or 6 feet down, you're really mining into something that's very much like the till that the glacier put here, 15, 18,000 years ago. So, and there's really nothing there for plant growth other than a lot of calcium, which is pretty abundant in the rest of the soil. There's no water. It's too compact to hold any water. So there's no reason for plants to go down in this sort of area. They'll spread out and they'll grow those sinker roots, a few feet down to harvest the water in that loose soil and over that hard parent material. And now think about nutrients. Where do the nutrients come from? Well, they come from decaying leaves and the decaying roots of other plants. That's what releases nutrients into the soil, and those are released near the surface. And so roots that are 40 feet in the ground would be all the other plants would grab the nutrients before they got there. So a tree has almost all of its fine roots very near the surface. It has a few deeper sinker roots that go down. I mean, if in a gravelly, sandy situation, they could go down sometimes tens of feet. In this situation, probably only a couple of feet, because that's really all that's available to them. So really the moral of the story here, and this is really important when you have trees around your house, because never think that because you don't actually hit the tree when you put it in a sidewalk or expand the driveway, that when you come up to the edge of a tree, if I come up with the edge of the tree and put the foundation right here, I've destroyed about half the roots of this tree. Because all the roots that spread out near the surface in that direction will have to be cut and eliminated. If the tree is young and vigorous, it may survive. If it's an old oak, it will probably die. So that's a good practical reason to understand about root growth in trees. All right, I want to talk about.
That's a lesson I always like to tell people. I get asked a lot of questions about trees around houses. The biggest reason why trees die is roots are damaged. You can trample on the ground, you can park cars on the ground, compact the ground and kill a tree. You can dig up the ground, you can put in sidewalks, foundations. That's not to say that you should never do those things, but be aware when you do those things, you're putting huge stress on the trees that are growing nearby. And if you have a tree that you really prize above most anything else and you really want to keep it, stay away from the roots. Doesn't mean you can't walk under the tree, but don't park your cars under the tree. Even human feet, crowds of people over long periods of time will compact soil to an extent that really damages the tree. So let's look a little bit at the crab apples and apples of our region. We're going to look at two. I'm going to slip in the exotic common apple also. This is the native Iowa crab apple of our area. And look at the simple alternate leaf. A leaf that sometimes looks like it's just serrate. Other times it starts to develop lobes at the base. Sometimes they're really obviously sort of three-lobed leaves. So a bit irregular there. This is the common apple, which has very much an elliptical leaf with a obtuse to almost rounded tip. The common apple, both of them are a little bit hairy. The common apple is hairier in most respects here. It's very fuzzy underneath. And common apples are probably almost as common as finding the native crab apples in our woods today because of the frequency with which farmers and the early settlers planted apple trees around their homes for obvious reasons to harvest the apples. And so those trees and their progeny from animals that ate the fruit and spread the seeds around, their common apples are really quite common in the woods. Look for this simple elliptical leaf and a very fuzzy leaf. Flowers of either of them look about the same. I mean, the common apple is just a crab apple growing in the kind of western part of Asia, where people figured out and they bred it for very large sweet fruits. So you end up with flowers that look very similar between the two. There's the Iowa crab apple. They're large enough. I mean, a crab apple actually tastes pretty good if you like sour things once it's ripe. And I would put that little diagram there because we're all familiar with apples and that funny little opposite the stem, there's that little pattern of little brown flakes. You know what that is? Those are the sepals of the flower. Apples have an inferior ovary. If you did our flower workshop some time ago, talked a little bit about that. The sepal, all flowers have sepal, petal, stamen, pistil. Sepal, petal, stamen, pistil. With the inferior ovary, the sepal, petal, and stamen fuse together and surround the ovary, and then you really only get free sepals and petals on top of the ovary. So when this matures into a fruit, this swells up into the apple, and it leaves the sepals here on opposite the peduncle, the stalk on which the apple is held to the tree. With a cherry, it's just the opposite. The cherry has a superior ovary. So if you look at the end of a cherry, you don't find the remnant sepals. The sepals were down here, and the cherry developed above the sepals and petals. Little botanical note. Again, when you're in the grocery store looking at fruits, you can give that little lecture to the person next to you. Here is an Iowa crab apple. And unlike the common apple and crab apples will have a bark that looks very, very similar. But with a crab apple, if you look closely, you'll start to see some thorns like this. They're often only incompletely modified thorns with a bud and maybe a leaf coming off the side, and they're not particularly sharp. fact, they're so dull, I sort of wonder what purpose they serve. That would be pretty hard to injure yourself on one of those. Maybe a large mammal might provide some resistance to large mammal feeding, but not much. Anyway, they're there. It's a nice identification feature, and it is absent on the common apple. That's the Iowa crabapple twig. And note that in telling crab apples from what we're going to do next, hawthorns, we'll take a little break, but we'll do next the hawthorns. Yeah, apples have a little bit of fuzz on the buds, in particular on the common apple is very fuzzy. So fuzz on the apples, both the leaves and the twigs and buds, more fuzz on the common apple, which is an introduced species, less on the crab apple, but enough that it makes it quite different from the hawthorns, which we'll do next. So let's take a short break here, and then we'll be back. When will we be back, Jackie?
Well, it's about 10:55 right now, so let's say 11:05. We'll return from break. So
Okay.
now's a good time if you gotta use the restroom or grab a beverage, just stand up a little bit. Otherwise, we'll hang out and take questions for the moment until everybody's ready to come back. There was a comment earlier I meant to share that somebody said serviceberry is great in pies.
They're sweet. They don't have the tartness of blackberries or something like that. So, but they are. I love to eat them. They're in southern Michigan. When I was my first year at the University of Michigan, I worked near Mayo, Sand Plains near Mayo, Michigan. And serviceberry was very common in there. And it was a year where we had lots of rain, and the blueberries and serviceberries were just massive amounts of them. And I remember going up to one fairly large serviceberry tree and just feasting on it for a long time. It was one of those experiences of wild berries I'll never forget and probably never experience again. The blueberries were in enormous numbers also that year, but the serviceberries are just delicious.
We had a couple of comments earlier too when we were talking about ironwoods and musclewoods that Veteran Acres in Crystal Lake may have some, and the Morton Arboretum has some near the Education Center.
Oh yeah, yeah.
How can you tell when an Iowa crabapple is ripe?
Well, it will turn color. I mean, it will turn reddish. It's like a common apple. It will turn reddish as it ripens. My experience, it doesn't turn as brilliant red as a delicious apple or something, but it will turn reddish. I mean, if you've got an Iowa crab apple you're watching, you could just taste it, a few times along the way. Even when it's ripe, it's going to be pretty sour. But you may be able to make nice jellies and pies from them. That tartness can sometimes lend itself to some of those sorts of desserts and treats. My aunt would make a crabapple jelly, and it was really good.
Nice. Well, that was all the questions we had in the chat for the moment. So,
Okay.
guessing we'll just hang out and people will be back in a few minutes.
Our puppy is getting old enough that starting to go for walks now, so couldn't do that for a little while, and I still look at all the trees on walks. I go on the same walk, you know, but the 10th, 20th time on the same walk, you'll still see things you didn't see before. You just there are trees all around you. In most places in the eastern United States, there are trees all around you, so there's always something to look at, trees and shrubs. What kind of trees do you have around your house, Jackie? I've never heard you talk about them.
Well, it's because I'm sad to say on the other side of my fence where I can't get them is a bunch of buckthorn.
Well, that's something.
So we have a red oak in our front yard.
Oh, that's good. Is that's something it was, it's probably a planted tree, not a, you're not,
Probably, yeah.
yeah, it's not a remnant. Well, you're fairly near what Deer Grove, so I don't know how much bigger the grove was in the past, but yeah, red oak's a beautiful tree. It tends to grows a little bit faster above ground than white oak. And white oaks, looked at growth curves. White oaks tend to catch up at about a century, but most people don't think in those terms. So
Stick around to watch.
yeah, but red oaks have beautiful form, fall color. Yeah, really nice trees.
Other than that, there's just a lot of the typical suburbia, you know, like maples and.
Yeah. Is your oak old enough to make acorns?
Mm-hmm. Got a lot of squirrels.
Do the squirrels plant the acorns around your yard? Do you
Oh
have
yeah, it's
seedling?
a little bit of a mess, but
You have seedlings coming up though?
no, not. Oh, we had the previous owner of the house left us a squirrel guard metal thing that they put around the tree.
To keep squirrels from going up the tree?
Yeah, so I got a nice little nudge from the neighbors. Oh, you should start putting that up around now.
This is so they don't get
Yeah.
little oak trees coming up there. Well, I don't know about that, but
Here is a question. Why do red oak leaves stay on so long in the fall?
well, that's a good question. I thought I knew the answer to that question, but then I'll tell you the answer to why oak leaves. White oak leaves will do it. Red oaks, hills oaks, pin oaks, many of them, particularly when they're young, and particularly in for the interior of the crown, they will tend to hold leaves well into the fall, even after they're brown, even well into the winter. So the explanation I used to give, and the explanation that I think was accepted, was that oaks had evolved from evergreen ancestors. Really, the oak diversity of oaks is much higher when you get down to southern United States and the Central America, Mexico. So it makes sense that an evergreen plants in much warmer climates would make more sense. But been told recently that's not true, and that oaks had actually evolved in higher temperate areas and then migrated into the tropics later on. So I don't know the reason why oaks tend to do that. It could be that the original explanation is still kind of true, and that just the oaks that we have in North America tended to originate from subtropical sort of evolutionary ancestors, or maybe there's another reason. But it's a good observation, because many oaks do tend to hold those leaves even after they're dead. It's like, why would you hold a leaf that was dead? What good is it doing you? And they do it. So there must be a reason somewhere back in evolutionary history of oaks. So If it's not evergreen ancestors, I don't know what it is. There are a lot of evergreen oaks. We don't think of oaks as evergreen, but there are a lot of evergreen oaks when you get down to the subtropics.
I have another question. Can you talk at some point on the types of forests such as beech maple and how they replace older types of forests such as oaks and other things?
Well, as you go east, rainfall increases. I mean, if you look at the original landscapes, even in New England, there were lots of oaks and grassy openings reported. So the ecology was probably less strikingly different than we think of it today. When you go to New England, you think of beech maple forest and birch, much more of a northern forest sort of character to at least southern New England. But originally, evidently, it was still at least commonly oak and grassy openings. That word prairie didn't come into it. That was a French word that really associated with the Midwest. But the idea of grassy openings were common there also. Beech and maple are both extremely shade-tolerant trees. And so they tend to dominate in areas where fires are not common events, which for many centuries has been the case with New England. That was settled, back in the, at least beginning back in the 16th, early 17th century. So it's had a much longer period of European occupation and with very few fires. And so the forests were transformed long ago. And this beech maple forest end up even into southern Michigan, where you have areas that were isolated from fires for a variety of topographic reasons, developed into those beech maple forests. So whereas as you move westward, rainfall decreases, the hardiness of oaks gives it in drought situations, gives them somewhat of a competitive advantage, and their sheer tolerance of fires makes them dominant as you get into the sort of prairie savanna areas of southern Michigan and even western Ohio and northern Indiana and Illinois and points west. It's really not that beech maple forests sort of replace, one forest doesn't replace another. What happens is that species that are extremely tolerant of shade yet sensitive of fire will expand their populations when you stop burning. And if you have beeches or maples growing nearby in oak woods, when you stop burning, they will expand and slowly transform that oak wood to beech maple woods. And that happened 300 years ago, in New England, and it's happening now in many areas of the Midwest. I mean, we're looking at one of those in coral woods. I mean, now we are doing prescribed burns in coral woods. I should add that. We're doing prescribed burns in coral woods, and so we're not clearing the maples. As far as I know, that's really John Peters' responsibility out there. He's done a great job of managing coral woods, and he's using fire in those areas. So it has slowed that transformation of the oak woods to a maple woods, and maybe slowly turning it back toward an oak woods over many, many years of burning. So, so there are a variety of ways to answer the question I asked you about what to do in cases of those invasion. But then that's maybe a longer answer than you wanted to the question. But I think it's about time to get going again, isn't it?
Yes. There was one question left, but we might save that till the end if you want to keep going.
Okay, let's move on and talk about hawthorns. And these are going to look a lot like, some parts of a hawthorn look very much like a crabapple, like the bark. I mean, I can't tell them apart. They're both gray and scaly on the outside, and when the gray scaly part falls off, it's a little bit orangey, reddish and orangey underneath, very similar bark. But this is a huge difference. The thorns are a thorn is a modified twig. And if you look at the thorns of an apple tree, you'll see they still have sometimes buds on the side of them, just like a twig, and sometimes even a little leaf, tiny little leaf next to the bud. On hawthorns, evolution has modified these into really specialized, look like surgical instruments. They are polished, shiny, and needle sharp. and easy to see why an animal would want to give these some space for your grazing animal. This would really hurt if you smashed your lips into that. Once as a boy running around at night, as I used to do, running around wildly at night, I ran straight into a hawthorn bush and ended up with scratches all over my face, and learned firsthand about hawthorns. Luckily, none of them poked me in the eye. Occasionally, hawthorns will develop these branch thorns. This is not something you would expect to see, but it does occasionally happen, particularly on the trunks of older trees. But out on the twigs, this is what you'll see: needle sharp, specialized spikes coming out off of the branches. You see it again. This is one of the diagnostic features of hawthorn. It's very different from apples. Look at those shiny red buds. The apple buds are always sort of white and fuzzy. A lot of fuzz on a common apple bud, somewhat less on an Iowa crab, but not these smooth, shiny red buds of the hawthorn. Sometimes you'll see those red buds right at the base of the thorn. Again, shiny and red. A number of hawthorn species in the Chicago area. I'm not really going to try to separate these today. Downy is my favorite. It has a soft, fuzzy underside to the leaf. Coxbury you'll probably see planted around homes, more the shiny green. We call that leaf a sort of spatulate shape, sort of cuneate, wedge-shaped at the base with a rounded tip. See, it's the thorniest. It's probably the most ornamental. The shiny leaves and masses of these shiny red thorns make it dangerous but pretty. The downy is probably my favorite. This is the one you'll see probably as often as any. This is an exotic hawthorn called the Washington hawthorn with these sort of lobed leaves. Now, most of the hawthorns that you'll see, either exotic or native ones, are unlobed. I'm not going to go into it, but some of the English hawthorns are lobed leaves. This is a little bit of that lobing on the Washington hawthorn. Hawthorn flowers are pretty, look very much like apple flowers, and like, for that matter, like cherry or plum flowers are all in the rose family. Little beautiful little white 5-petal white flowers. The hawthorn is like the apple. It has an inferior ovary. Here's the remnant sepals of the flower out here, and there's the hawthorn. You know, hawthorn tastes a little bit like a crabapple, maybe a little mealier, not quite as tart. I'm told, I don't do a lot of herbal cures, but they're supposed to be good for you. Maybe some of my participants today know a little bit more about the medicinal uses of hawthorns. Mulberry, here's another simple alternate leaf with a succulent fruit. I'm going to really focus on the red mulberry today, which I put this in here because it is not far away. South of us, you'll find it in some major river valleys. You'll find it in major river valleys to the west. I have not yet found it in McHenry County, but I put it in there with the hopes of finding it. I'm going to be searching Fox Bluff soon, and I'm hoping to find this there. It comes up these major river valleys. It is a species mostly points further south and east. So we'll be looking for it. But look, it has a leaf that, unlike most trees, it doesn't have one leaf form, it has many. You have a simple unlobed leaf. You have here 2 lobes, sort of mitten-like leaf, and you can have leaves with many lobes. The mulberry that you're used to looking at, there's the mulberry, which I've eaten millions of as a child. The mulberry, I thought I had a picture of the white mulberry leaf here. Let me just go forward. There it is. There's the white mulberry leaf. I put it in the wrong order. The white mulberry leaf is very shiny on top. Essentially all the mulberries you see in McHenry County and Lake County, as far as I know, are white mulberry, even though the berries are dark red in color. There are varieties of white mulberry that have white berries, but all the naturalized wild versions of it. This is an Asian species. It is exotic. It was brought into the United States for the silkworm industry. They love mulberry leaves. but it got loose. The silkworm industry didn't work out, but the mulberries did. So they're all over the place, particularly in cities and around human dwellings. There's the familiar mulberry there. And there is the white mulberry leaf, very shiny. The red mulberry leaf has a dull, flat green color to the upper surface. And we look at the bark of the two. Whoops, there's the bark of the white mulberry, much more orangey in color. Now, if you look at the roots of either one of these, they're bright orange, but the white mulberry has more of those orange colors in the bark, in the twig, in the buds, and you'll see that orange color in a number of places. So I just wanted to make you aware of the distinction between the two, and so that you wouldn't make the mistake that I made early on in my learning about trees, and everyone makes. You see a mulberry with many shapes to the leaves. You see that the berries are red, and so you think it must be the red mulberry. In fact, almost all the time, it's the exotic white mulberry. Now we're going to do a species that's rare in McHenry County in the Chicago area, but is still worth doing because it has some non-native lookalikes, exotic lookalikes that are mistaken for it. This is the native wahoo, Euonymus atropurpureus. The genus Euonymus has a lot of ornamental plants from Eurasia that were brought in and used for landscaping. Almost all of them get loose and occur in our natural areas, and we'll have to do those in a later workshop. But this is the native Euonymus, and the leaves on this are slightly fuzzy underneath, and that's how you tell it. I think I put in there's another picture of the native Euonymus. I think I put in a picture. There's the spindle tree, the European spindle tree, that does a good imitation. But this one has glabrous or smooth leaves without any hairs. So if you see a tree-like form of a small Euonymus, go up and look at the leaves. Euonymus is all in the books where they'll tell you it's opposite, but it drifts away from opposite. Look at that node right there. That's subopposite, much like a buckthorn, if you know your buckthorns. So Euonymus can drift away from opposite to be subopposite, but typically in the books they will call it opposite. The twigs are a bright green in color. This picture shows that less well. I think I have there's the fruit of Euonymus. This is the reason why people plant Euonymus as an ornamental, because these bright orange and pink fruits. And there is the bark of the Euonymus shrub, green. The twigs are bright green in color. As it gets larger, you start to see these corky ridges, but it retains that green color for a long time. So if you see a plant where the twigs remain green for several years, and it has opposite simple leaves, you're probably looking at a Euonymus. Simple elliptical leaves, these leaves at first glance could be a cherry leaf, it could be a buckthorn leaf. It may remind you of a crabapple leaf, whatever. All those others are alternate, but it has that simple elliptical leaf with a little acuminate tip. But this is the native wahoo. This one's pretty rare, so it's one I always want to make people aware of, because if you're doing restoration and you're clearing and you come up to Euonymus, it's probably an exotic, but you want to make sure before you cut it down. This is a pretty native tree of our area. There's the twig. I had a picture of that green twig and the paired opposite buds. Oh, there's some pretty flowers of the Euonymus. So let's do a little quiz on these last few. How about this one? So we're doing simple alternate leaves. So you want to look at the leaf shape, the venation, the base of the leaf, the tip of the leaf. Just look at those characteristics. So we have here, do you see it, that little cordate base, the little heart-shaped base? It doesn't jump out at you, but once you learn trees, you look for these features. You look right at it and you see that little indentation at the base. This is our serviceberry, a singly serrate leaf with a little short acuminate or cuspidate tip. How do we do on that one?
I had guesses for Juneberry.
Okay, Juneberry, serviceberry. I tend to call them serviceberries. I put Juneberry up there. That's I think Juneberry is the common name in the Florida, the Chicago region. It's a good guess. That's not an easy one. How about this one? Looks like the flower buds hasn't quite opened yet, but look at those leaves. Again, simple alternate leaves. Think of the things we've done just before the break and after the break. Now the leaves are somewhere between toothed and lobed. So what did we come up on with this one?
Iowa crabapple.
Yeah, it's Iowa crabapple. You guys are getting better. I think you're starting to pick up on things to look for. That's what it means to not becoming addicted. I mean, it'll last the rest of your life, but you know that's a good thing. How about this one? Look at the leaf shapes, leaf margin. So we've only done one thing that has multiple leaf shapes. Here you see a simple unlobed leaf. There is a 3-lobed leaf. Here is like a 5-lobed leaf. They're probably just mittens with 2-lobed leaves. In this picture, I can't quite pick them out. So that's the mulberry. Which mulberry? The red mulberry or the white? What do we get for that one?
I had lots of guesses for white mulberry.
Yep, exactly. I tried to pick a picture that had the highlights on the leaf that showed that shiny upper surface. I mean, in nature, you're going to see that pretty easily. It's just easier than with a single picture because as you're moving, the sun and your relation between the sun and the leaf surface is moving, and you see those highlights sort of coming and going. It makes it very easy to see. A still picture is much harder. And how about that one? Just in association with the last one, maybe that makes it fairly easy. But look at the surface of the leaf and the duller color, rather odd shape of the leaf. That's the native red mulberry. Again, it's good to keep these two in mind because as you travel around the Midwest and go to state parks, you will run into the red mulberry someday, and know that distinction. How about that one? This is tough. Got some lichens on the bark, but there's still enough of the bark there. Jackie said the bark was a little harder for people. That's no reason not to work on. You can identify almost all the native trees of the Chicago region by just looking at the bark. Not to say it's easy to do, but it's fairly. I mean, for some, if you do it a while, like I have, then it becomes relatively easy, and that's pretty satisfying. So, what are we coming up with for this one, Jackie?
Musselwood.
Musselwood is close. Yeah, this is serviceberry. Now, musselwood, very similar color, but what you're lacking here is the muscly sort of bulging. This has fairly smooth, rounded forms here to the true trunks, and not those. The musselwood bulging, the bulging muscle-like forms are really obvious on a musselwood. Here you've got the smooth gray color, very similar between serviceberry and musselwood, but here it's the serviceberry. There's only one tree we've had that has this particular feature that you're looking at right in front of you here.
Got a couple of guesses in so far for hawthorn.
Yeah, exactly. Really specialized long needle sharp thorn. These lobed leaves probably mean this is the Washington hawthorn. I didn't really expect you to go any farther than hawthorn on this. In fact, I mean, I find it hard to identify hawthorns in the field if it's not. The easiest ones are downy hawthorn and with one of the spatulate leaves name escaped from that now, and Washington hawthorn. Some of the others I have to take back and key them out. There's a whole story about hawthorns and why they're so variable out there, but I don't have time to go into that today. Ooh, how about that one? It's actually a very distinctive twig. We've only done one thing with buds like that, yesterday and today. All right, those shiny red scales, that's hawthorn again. Did we have anyone get that one right, Jackie?
I had a couple guesses for
Oh, good.
one.
Good. These are things that won't jump out at you until you see it a few times, and then they do jump out at you. That's the lovely thing about learning about trees. You start to notice all these details. Ooh, what's that?
Mhm. Got some guesses for Wahoo.
Yeah, that's wahoo. Look closely to see the more or less opposite arrangement. There's a little sub-opposite there. Those look pretty much opposite. And you see these pink and orange colors in the fruit and the green twig. When I'm identifying euonymus, I'm usually going right to the twig, the opposite arrangement, and the green twig, which is true of all the euonymus, and that gets me to the genus, and then I start looking at the other characters to go to the species level.
In 1859, a man named Charles Darwin wrote a book whose short title is The Origin of Species, in which he talked about the evolution, the process of natural selection guiding the evolution of plants and animals. And the key factor that drove that was competition. So I want to stop and talk about competition here for just a minute. There are winners and losers in competition. The two big dead trees over to the side here are cottonwoods. I mean, they lived a long life, so in a sense, they won the battle. They eventually succumbed to competition from other plants around them, but they lived long enough to produce probably millions of seeds. In the book, Darwin has this wonderful section that's later in the book, and he talks about the tangled bank. The tangled bank. And what you're looking at here is Darwin's tangled bank. I mean, it's true of every place you go, from the most beautiful prairie or restored oak savanna to this, well, rather homely bunch of invasive. Plants are competing with one another. Here it's so obvious. They're sort of crawling, literally crawling over one another, one on top of the other, trying to eke out an existence. And Darwin used the metaphor of the wedges. And he said, a community like this is like a bunch of wedges that in a finite space have all been packed in together. And every time you drive one wedge in farther, meaning it's taking up more space, it's pushing the other wedges out. And introducing a new wedge means that another wedge falls out. This is the metaphor for species that are dropping out as others invade and secure a place to live in that tangled bank. And that's what's going on in nature all the time. That competition here is so obvious, and we tend to think of nature, we still tend to think of nature in terms of a sort of idyllic peacefulness. That was certainly the dominant worldview in 1859, when the women of society were supposed to have said, one woman, after reading, people would actually read these popular science books. She said, let's hope it isn't true. But if it is, let's hope it never becomes widely known. That sort of underlying truth about nature as a world of intense competition and mortality is one that we often forget today when we do restoration, because we feel like we're trying to achieve a sort of balanced, harmonious state where everything is coexisting. But within that coexistence is intense competition. That's true in a beautiful native prairie. It's true right here. And that's the story of competition, a vital part of understanding how plants reproduce and maintain themselves in ecosystems.
So, little ecological lesson there. A book that I've read many times and will continue to read many times. Cottonwoods and aspens. Here's a group of plants that are particularly cottonwood common all over the Chicago region. The aspens, in fact, become more common as you get to this northern tier of Lake and McHenry County. In DuPage County, the aspens were very rare. I remember seeing them a little bit, but they were almost absent from the area. Funny, only a half hour's drive north, and aspens become a much more common part of the landscape. Here's eastern cottonwood. Look at that leaf shape. What does that remind you of? If you were in geometry class, you'd say that was a triangle, wouldn't you? And that's deltoid. Deltoides refers to triangle. Populus is the genus. Deltoides refers to this triangular shape of the leaf. It has a truncate base, pretty much flat across the base. Very unusual leaf in that respect. And its tip is a pretty nice acuminate tip. Acuminate tips are common on leaves, certainly not universal, but common amongst many woody plants. So a truncate base, an acuminate tip, and a deltoid shape. And those are 3 words you can impress your family and friends with. Here, rather ornamental, male flowers in the springtime. The flowers, as are many trees, the flowers are in catkins. They're red, rather showy for a while in the springtime. These are the matured or maturing capsules of the female flowers. Now with aspens and their relatives, the willows that we'll do next, it's dioecious. So the plants are either male or female. They'll have either female flowers or male flowers. Things like oaks and all the birch family things, elms, all those are both male and female. And for the most part, maples are both male and female, with the exception of box elder, which is dioecious. It has either male or female individuals. So that's an interesting sort of little variation you see in the world of trees. Here, all the populus are dioecious. Here's a female and a male here. The buds are very large and pointed. If you squeeze them, they're very resinous. They have a slight odor to them, not unpleasant, not particularly fragrant either. And the bark of eastern cottonwood toward the base is very deeply furrowed, but not dark as an oak bark. As you go up the tree on a cottonwood, the bark will smooth out and become much lighter in color. But at the base, you get this very deeply furrowed light gray bark. Trembling aspen, which outwardly I suppose doesn't look much like cottonwood. If you look closely, it does. One of the things I didn't say about cottonwood leaves and aspen leaves share that same, is that the petiole right here at the base of the leaf is very flattened. And so the leaf waggles back and forth very easily in a breeze. I suppose I maybe could have put a video in of waggling cottonwood leaves or aspen leaves in any sort of breeze, even a light breeze. You'll see these leaves with a characteristic back and forth waggling or flickering or trembling feature. And in fact, those leaves bump into one another and make a slight sound. So this is a characteristic sound of standing under an aspen tree or a cottonwood tree on a breezy day as those leaves hit one another. I always used to say that's the only tree I think you can identify by sound. Are the cottonwoods and aspens. So aspen, by contrast with cottonwood, has a more sort of overall round leaf shape with a rounded base and a short acuminate or cuspidate tip. The trembling aspen, which is much more common in McHenry County, has a sister species, big-tooth aspen, that is also here, and you will see it, but it is less common. This one is ecologically, big-tooth aspen tends to be in a little bit drier places than trembling aspen, but there's so much variation within the two. It's much like the difference between slippery elm and American elm. American elm tends to grow in wetter places, slippery elm higher in the landscape. And in the modern landscape, they're just all over the place, both of them. And it's hard to use the ecology to tell you which one you're looking at. But grandidentata, big-tooth aspen, will tend to be higher and drier in the landscape. Pretty easy to tell why it has that name, Grandy, big teeth, relatively few, but much bigger teeth, many more smaller teeth on the trembling aspen. Otherwise, they're really very similar. They have similar bark that's very light in color to my eye. The big-tooth aspen's a little bit more browny white in color, and the trembling aspen a little bit more greenish white in color, but it's a really fine distinction. Either of them will start looking like a cottonwood tree at the base with a fairly sort of light gray, deeply furrowed bark. This sort of shift back and forth between light, smooth bark above and gray furrowed bark below, really characteristic of the whole genus populus. When people see this white bark, they often instinctively say white or birch because they're thinking of paper birch. But if you look at the whole tree on an aspen, by the time the tree is 4 or 5 inches in diameter, it starts to develop this gray furrowed bark at the base, and that's really nothing like birch bark. The way to tell trembling aspen from big-tooth aspen is to look at the buds. The easiest way, the leaves are pretty distinctive. If the leaves aren't there, look at the buds. The buds of trembling aspen look like they've been lacquered and polished. I know a lot of things look smooth, but this one does look like it's been lacquered and polished, and the big-tooth aspen bud is covered in a sort of frost. Hairs so small they can hardly see them as hairs. It almost look like they're frosted white. Really pretty different. Willows, which don't look anything like like aspens and cottonwoods, are in the same family, the much larger willow family, the Salicaceae. And so again, they're dioecious. They're both male and female willow individuals. The individuals are never both. We're going to do just the willow, 3 willow trees today that I think all of them we commonly interact with if we're working out in natural areas. All 3 will tend to occur in wetter places. One of them is exotic and could grow anywhere, but if it's naturalized, it's frequently in wetter areas. This is a peach leaf willow, and if you know peach trees, we're a little bit north for growing peaches here, but I think some people still try, and they have a leaf that looks very much like this. There's a more broad, it's a broad lanceolate shape with a long acuminate tip, very graceful looking leaf. With a peach leaf willow, it's white, waxy. Is that epicuticular wax I mentioned, I think, yesterday, the soft wax on the surface that you can rub off with your fingers. So if you see a willow with a willow tree with these broad lanceolate leaves with a long acuminate tip, you're probably looking at the peach leaf willow. There's that lanceolate shape again, just to review. It does have relatively pointed buds. I mean, this is just a sort of generic willow twig, but I wanted to put this here because all the willow twigs, it's a characteristic of willows. This is not, you don't see a lot of separate scales here, do you? When you think maybe it doesn't have scales, but it does have scales. It just has one sail that slips over the bud like a sock and eventually pops off like a sock. If you watch a willow in the springtime, eventually this big scale will just start to split open, and the willow bud, which is very white and fuzzy, will start to push, the developing shoot will just push that bud scale off in the springtime. Black willow is outwardly very similar to peach leaf willow, but look at the leaf is narrower, and it characteristically has this, looking at it in the plain view, the leaf turns. It's called falcate. This one is turning, and that may seem like a subtle character. Again, if you get used to looking at trees, it's not that you won't find any leaf on a peach leaf willow that has a little bit of that falcate tendency, but if you look at the two together, you can see many more leaves on a black willow do this sort of twisting at the tip. And the underside of the leaf here is green. You're looking at the underside right now, green and waxy without any of that white waxy covering. Both of them fairly closely serrate along the margins. As either of these gets big, it's going to have a really rough bark, and they can get big fast. Either the peach leaf or black willow can grow into a fairly large tree, several feet in diameter. You usually encounter them as smaller sizes. But as it gets up about 6 inches in diameter, it starts to develop this rough bark, and then not much to choose from, at least to my eye, between The two, they have very similar bark characteristics. The weeping willow, which is, or sometimes called, in this case, the white willow. I call it the weeping willow here because that's what everyone calls it. It's the sort of typical common name. We've all seen these. They're, you know, they're very graceful. People love the form of them. They do grow very well in wetter areas. I guess you can grow them in somewhat drier places in cultivation, but they love the wet, and their roots will find your sewer lines very well and clog them up. So be careful where you plant them. But these pendant yellow twigs with a silvery green. We'll look at the leaves here in just a second. Sort of bicolored green-white leaves, so characteristic that we recognize these instantly. If you watch the movie Pocahontas, this is grandmother willow. But I hate to tell you, to break your bubble, but grandmother willow was an exotic species. This is an Asian species of willow. There are no weeping willows, native species in North America. So grandmother willow was a bit of an historical inaccuracy in the movie. Not that the rest of the movie wasn't perfectly historically accurate. Here, we're looking up a little bit closer at the weeping willow or white willow. We see the really white underside of the leaf, like peach leaf willow. These leaves are smaller, not as wide as the peach leaf willow. And if you look at the twigs are very yellow. I think I put a picture. The bark again, boy, the big willow tree bark is all so similar. I can't tell them apart. I thought I had a picture of the yellow twigs. I think we'll see that later. But maybe you can make it out here. The twigs are bright yellow. In the wintertime, if you go up to a weeping willow, it will have still a rather graceful, pretty form because it will look yellow. All the twigs are bright yellow through the winter. So that's an exotic species. It does naturalize here and there. Mostly when I see it, I think it's just a remnant from an old planting. But I've seen it in other places where it probably is a naturalized tree. Basswood. Now here's, this is one of my, I must admit, this is, I don't know why, it's always, you associate personalities with trees. I've always thought of basswoods as friendly for some reason. And so there you have it. It's a friendly tree. Basswood has a fairly broad, sort of ovate shape. The base is oblique or inequilateral at the base, sometimes more than others, but a broad ovate shape with a little acuminate tip on it. The bark of basswood, I couldn't find pictures that really worked very well for me. If you look at a young basswood tree, it's very smooth. And then if you look at it and see a lot of them, you'll see as it gets a little bit bigger, it starts to develop these vertical splits. And as it grows, it's like it gets too big for its britches, and those splits get bigger and open up and form these sort of anastomosing pattern of ridges and grooves. So the surface of the old bark is left on top of these flat-topped ridges. It's actually fairly distinctive bark. Once you learn it, it's characteristic really not only of American basswood, but of the little leaf linden and other species in the genus Tilia have very, very similar bark. Basswood's very soft wood, and if, as maybe it's obvious, as a kid I had to touch everything. And if you go up to a basswood tree and one about 3 inches in diameter and just put your hand out and tug on it a bit, you'll find it's very limber. It moves back and forth. Do the same thing with an ironwood, and it's very hard and stiff. The basswood tree is very limber and moves back and forth as you push and pull on it. There is a picture of a slightly younger individual where you see more of that surface of the original young tree's bark, and these splits sort of developing into the surface that eventually end up with a pattern like the one on the left. Basswood is an insect-pollinated plant. Someone asked about plants that might attract pollinators. This is one that has a lovely smell. It doesn't last for a long time, but during the peak of blooming, it has a just lovely odor. And if you have ever had basswood honey, it is some of the best you will ever have in your life. I had one jar of it many years ago, and I still remember it, so it was really good. The bees will tend to use one species more than others if they're available. And if you get bees using basswood, it just ends up with this lovely fragrant honey. And the flowers develop into this really peculiar fruit with the little balls that mature to ovary here in this accessory part here, this long bract with a little stem that comes off of the midvein of the bract on which the balls sit. Really bizarre shape that doesn't really, it looks like it's for dispersal by wind, but boy, it's a big, heavy, ungainly fruit. It really doesn't fly very far. I don't quite understand the dispersal in basswoods. Maybe animals subsequently eat the seeds and move them around because the wind really doesn't move them very far. They're not as aerodynamically as efficient, say, as a maple seed. And I stuck this one in because I had to. This is our only conifer we're going to do in the workshop yesterday and today. But it is a commonly occurring native tree of our region, so I wanted to stick it in. It's hard to group it with anything else because it's really not like anything else. It is a conifer, meaning it's a cone-bearing tree. The conifers evolved about 350 million years ago. Flowering plants, which everything else we've done is a flowering plant, evolved about 100 million years ago. So conifers, a much more ancient group of plants. And I can't, as I love to do, to go into the anatomy of conifers and how they reproduce and all that. It's fascinatingly different from flowering plants, but we'll have to skip all of that. This is, the word conifer means it's a cone-bearing plant. And you say, well, that looks like a berry, Tom. Well, it does look like a berry, but that's actually a cone. And if you look, if you look closely at these or on your own, because you'll find these are junipers, the name juniperus. Usually when we plant junipers, whether they're eastern red cedar or Asian junipers around our home, they will have these sorts of fruits. And if you go up and look at them closely, you can still see the scales of the cone. They're just fleshy and green. And if you crush them, they have a fairly pungent odor. It's the juniper berries that were the flavoring for gin. If you're a gin drinker, I was never much of a gin drinker, but maybe a little bit as an adult. I more like to smell it than drink it because I love the odor of these fruits. If you crush them and smell them, they have a very pungent odor. I wouldn't recommend eating them. But the birds eat them and they disperse the seeds of conifers. And this is one of the few examples. There are a few others, but one of the few examples of cone-bearing plants that have developed partnerships with animals for its seed dispersal. And we can see that characteristic leaves of the juniper are just these tiny little scales, and they can either be flush with the twig or they can be standing away from the twig like little spines. But these scales are the leaves of the juniper. Okay, one final quiz, and they'll be ready for us. So I'll wind it up and we'll be ready for our to finish it up for today. So there's your first tree. Look at the leaf shape, leaf margin.
Well, I've got lots of willow guesses, a couple.
Okay, willows,
weeping
that's
willow
good.
or black
You're in the
willow.
right group. All right. How many got black willow? Because that's black willow, and I deliberately picked one that had a really exaggerated falcate shape here. You see how you would normally expect a leaf that's symmetrical around the central vein. That's more or less straight, but here the center vein just kind of whoop, whoop, goes off to the right or the left and creates this sort of interesting falcate shape. So that's the black willow. Oh, how about that one? This is all. I'll give you a hint. I'll say this is a willow. Which of the willows that we've done is this?
Getting a few guesses in the chat for weeping willow.
Yeah, that's it. Bright yellow. This is, I picked this out because it showed the yellow bark, but it's not at all an exaggerated picture in any way. The twigs are really bright yellow by late summer into the fall, and what gives willow, even after the leaves fall off, a very graceful, pretty form. So we're dealing here with a willow or cottonwood or something we've done since our last quiz. Which one would that be? Look at the overall shape of the leaf form, the leaf tip.
Got a couple of guesses for peach-leaved willow.
Yeah, that's it. You guys are getting good. So yeah, it's one you recognize for a willow. I mean, we'll do shrubs in our shrub workshop later on this fall or winter. You'll see in shrub willows we have a lot of short, dumpy leaves, but with the tree willows are often long, narrow leaves, and this one's just a little bit fatter here. It really does do a good imitation of the actual peach. And there is another. It's another willow. Which of the three willows would it be? Okay,
Guess for peach-leaved willow.
Okay, well that's a good guess, and there's no scale in these photographs. This is the white willow or weeping willow again. If I could put a branch of the real thing, the two next to one, you'd see the peach leaf is quite a bit larger, and it's while you could say this is a lanceolate shape, it's the widest point is right about in the middle. The peach leaf is much more obviously wider at the base. It has a more graceful lanceolate shape to my eye than the weeping willow, but these leaves are much smaller. So that was a hard one because you don't really have a scale in these photographs. Oh, that's a good one there. Prime example. Okay, what are we getting there?
Got some guesses for aspen, both big tooth and trembling.
Okay, this would be the big tooth aspen because there are relatively few larger teeth along the edge of the leaf. And there's our trembling aspen by comparison. I mean, in this photograph, it's really hard to make out the teeth, but they're much smaller. So really similar in many other respects. Remember the frosted bud of the trembling aspen and the lacquered bud of the frosted bud of the big tooth aspen and the lacquered bud of the trembling aspen, but otherwise, from a distance, they look much alike. Oh, here's our friend that I've known this guy ever since I first started to learn about trees. It just grows everywhere in the eastern United States, and that's our
guesses for eastern cottonwood.
Eastern cottonwood with a nice truncate base and more or less triangular shape. Ooh, I'd forgotten I put this one in. So what are we getting for this one?
So far, radio silence.
Radio silence. Remember it's a broad leaf that's inequilateral or oblique at the base. Look at this.
There's all the guesses.
Yeah, look at the
basswood.
Basswood. See, this is the bract. This is that sort of the branch that comes off the bract. Still in flower in this case, doesn't have the little ball-like fruits. So we've come to the end, but not quite, because trees really are the gift for the rest of your life. And I actually mean that, because it's something I had managed to ignore them basically until 1980. I saw trees and I was around trees. I liked the outdoors, but I sort of walked under them, around them, and would climb them and would eat mulberries out of them. But I wasn't really much aware of them other than that until 1980. And I was on a camping trip with my father in the Blue Ridge of Virginia. And my father was retired at that time, and I was walking, and he had been doing a little outdoor work, and he grew up in Kentucky, in a small town, and was just an outdoors kid, for an outdoors, outdoorsman as he grew up, and he had a copy of the field guide to the trees of eastern United States, the Audubon guide, which with him. And one morning I was intrigued by this. I didn't actually know anything about trees at the time, but I was intrigued by it. So I saw the guide. I think my father was still asleep, and I picked it up and I walked away from camp along the trail, and I saw this funny shrubby oak. I think I knew enough about trees to think it looked oaky in some way or other. And so I started looking through the Audubon guide and flipping through the pictures back and forth, until I finally satisfied myself that it was bare oak, Quercus ilicifolia. I looked at the distribution on the range map, and it said it was a shrub to a small tree and all that, and it seemed to match exactly what I was looking at. And of course, I was 1980, I was 28 years old there, so I wasn't a kid. But what does any young person do? He runs back to his father to tell him what he just learned. So yeah, I remember that moment so well. I was so proud of myself that I'd figured something out. Well, that was the first tree I ever identified. I never saw it again till 37 years later. I was walking with my older daughter, Katie, in the Brooklyn Botanical Garden. We were visiting my younger daughter, Lily, who lived in New York at the time. And my daughters know the way to keep me in good humor and to keep me occupied is to take me to the nearest botanic garden. So they did. And Katie took me to the Brooklyn Botanic Garden, and we were walking around, and I could do that forever, walking around, looking at trees and shrubs and other plants. And I came up to this, low shrubby thing, and I looked at it, and I just paused and took a double take, like, oh, that looks familiar. And then I looked, of course, it was a botanic garden, so they had a sign there. It said Quercus ilicifolia, bare oak. And I thought, oh my goodness, this is the first tree I ever identified back in that summer in the Blue Ridge. And then I realized that I'd done it with my father, and there was my daughter. They never met each other. And that, the tree sort of connected the two. It was really a wonderful moment. And it's one of those things that trees do for you in life, is they connect all these things together in time. Sorry. But that's what I mean by trees are a gift for the rest of your life. Now it's really over. I will stop sharing there.
All right, so we will take any questions you guys have, and we'll be here. So feel free to unmute yourself to ask or type it in the chat.
I expect lots of questions, guys. This is, you can't possibly know it all, okay? If I don't get the questions, the next time I see any of you, I'm going to start asking questions because you obviously know the answers.
We had a few thank yous and well done and learned a lot. So thank you guys for the positive feedback.
Well, it's been fun to do. I love to teach about trees. It's a lifelong sort of love. It's where I started my study of nature all those years ago in 1980. And yeah, never leaves you behind. You'll be doing it for the rest of your life.
As a comment, the leaves on the bare oak looked like they had small points on the tips. Was that right?
Yes, they were. It's a member of the red oak group. It's a group of if you go to the southeastern United States, you find a lot of things called scrub oaks. They're sort of shrubs to small trees. The acorns all look alike. Bare oak really doesn't occur in the southeast. It's up in the Appalachians, but it's also one of those scrub oak species that when I encountered it was growing more as a shrub, and it wasn't the picture I showed you, but I guess it can grow into a small tree, but it is a member of the red oak group.
Hey, Tom, it's Tricia.
Hi, Tricia. How are you today?
Hi, greetings from Southern Illinois. I have never really heard of peach willow. Where does it grow?
Peach leaf willow is pretty common up here. It's one of the more common native willow trees of our area.
And then in northern Illinois?
Yeah, well,
Wisconsin?
it is relatively common in northern Illinois. I don't I have to go to Southern Illinois and look around to see if it's there. I mean, it's much wider leaf than black willow, and it has that white underside. If it's, if it's a big willow tree and it has those peach-shaped leaves, it's a good chance that it's peach leaf willow. Their willows are so diverse. There's so many of them. Really, to be sure, you really have to see it out. But it's relatively common in northern Illinois.
I'm going out and doing field work in a little while to the Crab Orchard Wildlife Refuge, so I'm going to be looking for it.
Okay. Okay.
Thanks. Great.
Awesome. We had a question asking about best books for tree and shrub ID.
Well, I sent some resources to Jackie, and what I've done is to put together a short list of books that I used and trusted, and they were really useful to me when I was learning. I mean, anyone can go to Amazon or the internet and get a list as long as your arm and your leg together. And they're probably all of them useful. I mean, to me, what I'm endorsing are books that I've used and I wore them down and tattered them and tore them apart because I used them so much and learned to trust them. What I will say is that whichever one you pick, if you wait until you don't know something to look at it, it's not going to tell you as much as if you take things that you know, like the silver maple in your front yard, and you look at it and you look to see how that author describes a silver maple. And then you go to the red oak that you already know, and you see how the author describes a red oak. And you go across the street to look at a little leaf linden. I mean, you do that over and over again with things that you know. You have to get to know the author's language and his style and how he describes things, and then you'll learn to trust what he's saying, he or she, and it'll be so much more useful when you're trying to work with something you don't know. If you wait to crack the book when it's a real puzzling thing, then you're sort of working against the learning curve there. You got to get familiar with a author, and then it becomes much, much more useful. So regardless of whether you start with the one I did, which is Audubon's Guide to Trees of the Eastern United States, which I always give a big plug for because it was so important to me when I started off, and the dendrologist who wrote it, Albert Little, is such a good dendrologist. I still look at that book and marvel over the descriptions and how accurate they are, and that's not really the case with all books. There are a lot of mistakes out there. I won't mention any of them online, but there are a lot of mistakes out there. Albert Little, as far as I can tell, didn't make any mistakes. I think it's just the push of editing these days is such that books are not, the push to publish is so strong that the editing is not as careful as it used to be. And that there are good things about the modern age and the tremendous amount of information you can get at your fingertips, but it means that a lot of information gets out there before it's properly edited.
We had a follow-up question of where will we post book references. So I will send a follow-up email when these webinars are posted to our YouTube channel. And in that, I will include some links, the information that Tom sent. So that way I don't have to send you like 3 separate emails about all that.
So I can just tell you, it's Guide to the Trees of it. It's Audubon's Guide to the Trees of the Eastern United States. I can't remember the exact title. It's May Watt's Tree Finder, which I've never encountered a resource that was as popular with students as that. I've never had anyone complain about it. They love it. You'll love it if you're starting your trees. That's probably the place to start. I think that plus Audubon's Guide together are a really nice little library for starting to learn trees. And you can always expand from there, but that's a nice little two-book library to start with. Things like Durr's Manual of Cultivated Trees. Again, I don't remember the whole title, but that one is really nice because you will encounter lots of trees and things around suburbia that aren't really widely naturalized or naturalized at all. You'll still want to know what they are. That's a nice one for that. There's plants, that now called the flora of the Chicago region that you probably don't want to buy. I don't think it's even for sale right now, but it costs $100 and some. But in the library, it's a really nice resource for if you know the species, you can look and find just all sorts of association with insects and other animals, the distribution, some local ecology, just tremendous, tremendous resource for learning once you learn to identify it. Not many people would carry a 25-pound book with them in the field, but it's a really useful book. It has a tremendous amount of information. And the shrub. There's a Simons and Simons shrub ID book that I've got on that list. That there's the one I used. Maybe it's not the best, but it's the one I used and trusted. And my copy is all dog-eared and worn out because I used it so much over the years. Large format book. It's not a field book, but it's a really useful guide. So that's a sort of, yeah, there are lots of good books out there. You know, Peterson's guide, the Peterson series of guides on many things are very well edited and established, and they're always good. I find with trees that pictures are better than drawings. Just like with flowers, I find that drawings are much better than pictures. With trees, I find pictures are much better than drawings. And so I tend toward the Audubon guide for the trees and the Peterson guide for the flowers. But, you know, take a look at both of them.
All right, next question. Is there an importance to softwood versus hardwood?
Well, as those words are used by foresters, they mean softwoods are conifers and hardwoods are flowering plants. And it really has very little to do with the softness or hardness of the wood. It's about the structure of the wood and the fact that conifer wood is different from the wood of flowering plants. I don't really want to go into the sort of cellular structure of it, but it's a different, the water transporting cells are different in the two, so that conifer wood, it makes better newspapers. The tracheate vessels in there are longer and make good cheap newspaper better, and some other things. So softwood, that's the way usually you hear those two, but in common use, you know, a maple is really hard. The soft maple and the hard maple are really just referring to the hardness and softness of the wood. But the classic way in which those two words are used are to make the distinction between conifer wood and the wood of flowering trees like oaks and elms and basswoods and or all that. You know, wood, ash, elm, all those are hardwoods, even if the wood isn't particularly hard.
What is a source for tree propagation information?
Oh, I think I don't have a good one right on the top of my head there because I've never done it. Are you still on, Tricia? Do you know one? Doesn't the Arboretum put one out?
You're muted.
Muted. You're still muted.
Sorry, you know what? I was looking at the Audubon tree ID. Sorry. I was looking to see if I could order it because I love a good ID book. What was the question about the Arboretum?
The question was whether you have a guide for propagation of woody. Propagation guide.
I don't think the Arboretum has one, but we do. I mean, there's several good resources. I'd have to look. I know. Did Durr do one?
We'll have to get back to you on that one. I know Lori Ryan, our plant ecologist, has some guides on propagation. We'll have to get back to you on that. I'll try to include that in the things that Jackie sends out later.
Yeah, because I remember the book Seeds and Propagation.
Yeah, I remember that book also. I just can't.
Yeah, that's the one I was thinking of, but I don't think it came out of the Arboretum.
Yeah. Okay. Thank you.
Yep.
Any other questions?
We have kind of a fun comment. My exposure to trees seemed to start as a young golfer. I always seemed to wind up behind one. I then learned to swear.
Yeah, well, trees play a lot of different roles in life. I mean, trees connect your life together once you learn them, and probably now that you're starting to learn the trees when you play golf, you won't just be behind a tree, you'll be behind an elm. Or you'll be behind a willow, and when you hit the ball and it bounces right off the trunk, you'll always remember bouncing it off of an elm tree or a willow tree. So again, trees become a part of those stories in your life.
It reminded me there's an earlier comment I forgot to bring up. There's a series, Draining the Oceans. Have you ever seen a graphic artist drain the trees from a forest and guess what it looked like before?
Draining it. I didn't.
If you took all the trees off the landscape, what would it look like?
Well, that's been done in lots of places. I mean, when you, in the Chicago area, you often have, I mean, we're talking about clearing forests. I mean, the Chicago area has lots of places where we completely eliminated tree cover. I mean, Glacial Park has lots of woods left, but lots of places within the park where the trees have all been removed. You have to be a pretty good detective to figure out where the trees used to be, and because herbaceous plants will simply colonize those areas, and they were used as pastures or hay fields, the trees didn't grow back. So
Well, that is all I see for the questions in here. So here's your last chance, or we're gonna start saying our goodbyes for now. But I'll say a reminder while we're here. The videos will be posted on Monday on our Discover MCCB YouTube channel. We'll send out the list of book resources via email then too. And doesn't look like anybody had additional questions, so we'll give it over to Tom for parting comments.
well, I just want to thank you for joining me today. This is, as I say, this is where I started as a naturalist many, many years ago, and it's where I like to return figuratively and actually go outside and look at trees. So it's something I enjoy sharing with people. I hope it becomes as much a part of your life as it is of mine. So I'll have to say so long for now, and I look forward to seeing you at the next webinar or seed collection site or wherever, for those of you who are in and around McHenry County. Bye for now.